It's time for us to put research in focus as we drill down on rapid device prototyping. I'm joined today by Dr. Dean Mohamedally, who is Senior Teaching Fellow at University College London, and Peli de Halleux, a Principal Software Development Engineer at Microsoft Research. Welcome, gentlemen.
Thank you.
So we've already heard about rapid device programming, prototyping. So before we go any further, I want to ask you about kind of the devices that I think you brought today. If we start with you, Dean, you've brought something called an Arduino.
Yeah, this is the Arduino.
And so what's unique about it?
So this is a custom Arduino board that is specifically designed for teaching. It was designed by the Autonomous Systems Group at UCL under Professor Stephen Hales. And this device has several components that are integrated onto the board specifically for teaching high school kids.
Okay, so students are building prototypes using this device?
Yes.
Put it down. And how much training do they have to need before they actually start building?
No training. They get started with the tutorials that we give them, and within 2 hours they'll be building apps with it.
Wow! And am I right in saying that the undergraduates are also helping them learn? But I mean, isn't coding and programming language fairly an arduous task to learn?
So the TouchDevelop scripting environment enables the features that are available on this board to be programmed relatively quickly. And so it's really down to the problem-based learning scenarios of what it is that the student wants to learn from. The first year undergraduates at UCL's Computer Science Department have a task of developing what we call the coding curriculum. So they have been already learning how to program code, and they have to create instructional guides for schools and school children to use with the Arduino.
Right. So these high schoolers learn to use the Arduino using TouchDevelop?
Yes,
am I right?
TouchDevelop.
And so you can describe some of the apps that they've built.
So some of the basic applications, so it has a thermistor that can record the temperature. It has several LEDs to send signals and issue animations with. It has an infrared to transmit from one Arduino to another bit of information that is captured. It has an accelerometer, 3-dimensional, and a gyro. So we can do things like, for example, a person who's slouching or a person who, they're falling. We can detect that motion and record that. We can then use TouchDevelop to graph this data, and so students have an ability to envision their science discipline with the Arduino capturing data and analyzing data.
And how long does it take them to build one of the prototypes?
So with the initial guides, between 2 to 3 hours, but if they wanted to do much larger projects, within a day or two that they can actually construct some very nice applications, yeah.
Peli, you've been waiting patiently whilst Dean explained his project. I know you've got a device. Could you show us what it is and explain what's unique about it?
So the first device I have today is the Raspberry Pi 2, which is a great device. It packs a lot of punch. It's a mini computer for under $40. It runs Linux, but also recently Windows 10. So you can go and download a pre-release of Windows 10, and it's basically a computer. It doesn't look like so, but you can do everything you would do on your Surface right now.
I'm guessing that opens up all sorts of devices that can be built on the Raspberry Pi. Can you talk about some of the prototypes that you've developed?
So one of the prototypes we developed at the office is a way to charge for coffee. So there's a website running on the Raspberry Pi that is connected to a card reader, and then you go and you swipe your corporate card, and it charges you $1, and then you can get the fancy coffee, right? And that's enabled by the fact that we are able to compile and run our TouchDevelop scripts on the Raspberry Pi pretty easily.
I like the coffee charging. It's really good, actually. We hear a lot these days about the Internet of Things. That collection of sensors all around us. How might a rapidly prototype device be used with the Internet of Things?
So you can, when you talk about Internet of Things, you talk about sensing and maybe sending the data to a website and then analyzing an array of sensors. So these devices make it really, you don't really have to do a lot of hardware development, because you can buy off the shelf a Raspberry Pi and put your software in it, and then and quickly prototype maybe an array of devices and so forth. And also they're getting cheaper and cheaper. So you don't have to do a lot of upfront investment to start trying these things out and prototyping. And then again, it's a full computer, so whatever you've been doing on your desktop, you could actually run it on these, which makes also the story a bit easier.
And you're working with a lot of youngsters, you know, how to use code and rapidly built devices, prototypes. Can you describe this project?
So, so TouchDevelop in general is an environment that allows you to code on phones and tablets. It's designed to be simple, just to deal with the space you have on the small screen. So in that sense, it naturally goes to students who are learning coding because it's a simpler environment. And of course, we use that. So we've been very successful in schools that, you know, for kids to try to learn building simple games, but also it expands to now IoT. You know, what do you do with devices, right?
And do you have? Can you explain a little bit about the Microbit project?
All right. So one of the other projects that we're very excited about is called the BBC Microbit, and I got one here. I'm going to turn on. So this is the second generation of the Microbit, and it's a project from the BBC with a lot of industrial partners, and they're planning to manufacture 1 million of those and have every 11-year-old in the UK learn some programming with them. And again, this is a little device. It has a chip in it. You can program a 5x5 LED array. It has buttons, has a bunch of sensors. So a lot of things, for example, that Dean and his team have been doing would be applicable with this device. And in Microsoft, we're very proud to be a big partner in the Microbit project with the BBC.
And how does the BBC Microbit compare with, say, Dean's Arduino or the Raspberry Pi?
So this is a full-blown machine, and this is a much less powered device,
Okay.
right?
Yeah.
And it's also a different price point. And it says that this is going to be much cheaper than this device. And it's really not, this is a simpler, in a sense, more, it's really an embedded device. It's a simpler environment, and it comes with sensors, while in this case, you actually have to add the sensors. So they're solving different problems. And it's very similar to the Arduino in the idea that for kids you want a solution that is all-in-one, that's already ready to use, and it has some really interesting sensors and also some very rewarding visuals. The LEDs here, the color LEDs are very rewarding when you do coding, and the same thing with the LED array. You can do a lot of cool drawings and animations on this array. So it's important that the kids get rewarded, or they can visualize what they're doing with the sensors.
And what sort of applications are teenagers developing with the Microbit?
So the Microbit is fairly new, but you could think about maybe little games,
Okay.
or scrolling text, because we have 2 buttons. Maybe they can talk to each other, so you can do games in there, leveraging the sensors. Hopefully a lot of for example, the learnings that the UCL team has done can be applied to the Microbit if we have access to the sensor.
Obviously, both of these are based around youngsters learning by doing. Dean, I wonder if you could just explain the educational theory behind this approach.
Certainly. So 4 years ago, we began doing apps development work with our first years and giving them real-world problems with clients to solve. And in the field of constructionism, this is a field which Seymour Papert had been involved in creating. There's been a very large growth in solving problems that are learning by doing, where you have tangible artifacts in your hand and you have the mental models to actually invoke what the artifacts of knowledge are and help to reinforce others. So you see one, you learn how to do it, you approach it with a scaffolding, so you find the process of it, you can then convey it to others, so you teach it to others. So your ability to express what you've built to other students, that enforces the knowledge domain transfer. And so in our coding curriculum, Ray Harbord, our UCL group, has been in charge of 120 of our first years, all putting out this coding curriculum material for schools and engaging with schools to trial this type of development work with hands-on material and assets.
Yeah. Peli, you mentioned earlier about the UK computer program that the BBC are running. Can you just expand on that? What are the goals of teaching 11 to 12-year-olds?
You really want to spur a generation of kids who are going to be interested by technology. And even if they don't become, let's say, a computer scientist, but they become a doctor,
Yes.
they might actually have a different view on how to approach medicine, because now they have in their luggage knowledge about how to build these kind of artifacts or think about devices and hardware. So that's, I think, one of the big goals that the BBC has. BBC wants to really prepare for the future, where technology is definitely an important aspect.
Definitely.
And you mentioned about TouchDevelop earlier. I understand this is something you're heavily involved in. Where's the future for TouchDevelop?
The future is you should download it in your phone and be coding in the train. We're very excited to be everywhere. We are very excited to be with the BBC. Our vision was always that people should be able to code on their device. So we'd love to be on every device. If you want to be creative on a device, that's our vision. We want to be able to go and just do it. And we want to be simpler. We want to. It's always, how can we improve it? How can we have people learn faster when you don't have help? Like you want to learn coding, but nobody around you can help you. How can we make that happen? Is there automated ways we can do that? Can we give you hints? Can we give you help? So these are all kind of research questions around computer science that we're looking at as well.
I've got one last question for both of you, so I won't keep you too long. Steve Hodges and Rostron talked about the collaboration earlier between industry and academia. Can you just speak about the collaboration with one another and how it's been beneficial?
It has been fantastic that the TouchDevelop team have come on board with our UCL students. We've acted as client relationships with UCL, and the ability for requirements to come through which are practical. This has really encouraged our students to say, right, they're building applications for a very visible product domain that they want things to be launched with, and to have it running in schools and seeing children actually doing these things, there's a very strong motivation of, hi, this is really in alignment with where technologies are heading. And like you said, so there's a generation of kids that will grow up and that they'll say, right, we learned to program with these things with Microsoft, and now we're going to become medics or architects, and we have the skill set. We can build rapid prototypes and apply ourselves with the knowledge that's been gathered from this relationship. Yeah.
Dean, Peli, it's been an absolute pleasure talking to you and learning about the educational value of rapid device prototyping. Good luck cultivating the next generation of tech-savvy kids.